let's talk about functions and their inverses. So if we have a function y equals 4x, the inverse of that function is y equals 1/4 x. If we have a function y equals x plus 2, the inverse function is y equals x minus 2. If we have a function y equals 3x plus 1, the inverse of that function is 1/3 parentheses x minus 1. The function y equals x squared, the inverse of that function is y equals the square root of x. That one has a little caveat by it we'll talk about later. The function y equals x cubed, the inverse is y equals the cube root of x. So I don't know if you can see a little pattern developing, right? When the function was 4 times x, then the inverse is 1/4 times x, or x divided by 4. When the function was x plus 2, the inverse was x minus 2. That next one really shows it pretty well. 3x plus 1. Notice that it's x minus 1 and then times 1/3, right? And then x squared, the inverse is the square root. And so I hope you can see that the inverses are what undoes the function, right? Think about solving for x, what would you do? You would do that operation that is the inverse, okay? So to be able to find the inverse, we will use a little strategy at the bottom of the page. So an inverse function switches the input and the output of a 1-to-1 function. Okay, and that's why I put a little star by the y equals the square root of x, because notice y equals x squared is not a 1-to-1 function, so its inverse is actually really not just the square root of x, it's just not perfect. So what we have to do on this will be a domain restriction to make the inverse work. The notation for a function is f of x. So if you're going to find the inverse, the notation is f inverse of x. So it's a little raised to the -1 power in a way, but that's not really what it means. It means inverse. And you could say it as f inverse of x. And then to find the inverse, like I said, we're going to follow a little strategy. First, switch the x and the y, and that's really creating the inverse, right? Because the inverse switches the input and the output, and the x and the y are the input and the output, and then solve for the new y, and that will create the inverse. So let's take a look at an example of that on the next page. Okay, so our original function is f of x equals 3x plus 8. Our directions, which should be up here at the top of the page, are find the inverse, which will be f inverse of x, and graph both the function and the inverse. So we're going to graph both on the same graph and see how they compare. All right, so first of all, we're going to take our function and write it with a y. Y equals 3x plus 8. Okay, so all I did was change f of x back to y. Now we're going to switch the x and the y location. So x equals 3y plus 8. So this, all we did was switch x and y. That creates the inverse. This is the inverse function. It's just we usually graph y equals something, so it would be strange to leave it as x equals. Okay, so we're going to solve. The next step is to solve for the new y. Okay, so we need to get this y by itself, so first we need to subtract 8 from both sides, so x minus 8 equals 3y. Now we'll divide both sides by 3, so y equals 1/3 x minus 8. Okay, it can be x minus 8 over 3 if you want, that's fine too. Okay, and then this would be y equals 1/3 x minus 8/3. Okay, so the inverse, in other words, is f inverse of x is equal to 1/3 x minus 8/3. Okay, so let's graph these. I'm going to graph this first one, y equals 3x plus 8 first. So the 8 is the y-intercept, so that's right here on the y-axis. And then the slope is 3, so that means up 3 over 1. Looks like I need to go down 3, back 1. Down 3, back 1 a few times. Okay, now I'm going to try to draw a straight line through those points. And I'm going to continue it right off the page if I can. Close. Okay, now I'm going to also graph this inverse, which is 1/3 x minus 8/3. So 8/3 is like negative 2 2/3, right? So somewhere around here. And then my slope is 1/3 this time. So that's up 1 over 3. So up 1, 2, 3. Okay, and then let's go back, down 1, back 3, down 1, back 3. Lovely. Okay. So take a look at that graph for a second. You'll notice, I hope you don't feel like those lines are perpendicular, right? Perpendicular would be a right angle. They're not intersecting at a right angle. Their slopes are actually just opposites of each other, not, reciprocals of each other, not opposite reciprocals, right? The one slope is 3 and the other slope is 1/3, so that's a reciprocal only. And what they do actually is they reflect. Let me show you if I draw in the line, y equals x. That's that diagonal line. Okay, hopefully you can see then, you can notice that the lines would reflect onto each other if the graph was folded at y equals x. Okay, let's do another example. And let's do the exact same process, okay? So we have the graph f of x equals square root x minus 2. So let's find the inverse first. So y equals the square root of x minus 2. So first, we're going to switch the x and the y. Okay. So all I did was reverse the x and the y location. Now solve for the new y. So I'll write that down. Switch variables, x and y. Okay, now we're going to solve for the new y. Okay, so I have the square root y minus 2. That's what I need to get rid of first. So I'm going to say y equals the square root y minus 2. I'm going to square both sides. Okay, because the square and the square root will undo each other, right? So now on this side I have y minus 2, and on this side I have x squared. All right, now it's y minus 2, so I just have to add 2 to both sides. So y equals x squared plus 2. So my inverse is f inverse of x equals x squared plus 2. Great. Okay, now let's graph this and see that we need to restrict the domain of the inverse. So first, let's graph this in this purple color, the square root of x minus 2. So that is the square root graph, and then it is shifted. Remember, this is a shift. Let's see, it's x minus 2. We do the opposite to x, so to the right 2. Okay, so 1, 2, right there. And then just do the square root graph. So it goes over 1 and up 1, and then it would be over 1, 2, 3, 4, and up 2 right there. Okay. I just did like a real quick transformation graph on that, right? You can do a whole table and stuff if you need to. All right, so this is the square root graph. Now remember, and that's all it is. There is no other part, right? Now, if we're going to graph the inverse graph in blue here, that's x squared plus 2. So notice that it's just a squared graph and it's up 2. So this is a shift up 2. Okay. So notice that what happened to the x's in the original is now happening to the y's in the inverse, because remember, we switched the x and the y's. Okay, so I'm going to go here and then here. Okay. This is my inverse graph, right? But notice that x squared plus 2 would also be over here. But that is not part of the inverse because it doesn't line up. It's not the inverse of square root x minus 2. Only this portion is. Okay, so let's also graph the line y equals x. And you can see that the inverse is a reflection over that line y equals x. So this is all we need of this graph. So we need to restrict this domain. Okay, so this domain can only be 0 and up. So x values are 0 to infinity. And while we're at it, we'll just say what the range is. Notice that the graph starts in the y's at 2 and goes to infinity. So bracket 2 to infinity. Okay, so that would be our final answer. It would be the x squared plus 2 graph, but it would also restrict the domain to 0 to infinity. Now I want you to notice something. On the original graph, what is the domain and the range? Okay, the domain is the x values, right? Notice that the x values start at 2 and go to infinity. Look at the y values on the purple graph. The y values start at 0 and go to infinity. So the range is 0 to infinity. So please notice, okay, this is what makes the domain and range easy on the inverses. They are switched, right? So the domain of the original is the range of the inverse, and the range of the original is the domain of the inverse. And that will always happen because remember what we're doing, we're switching the x and the y. So of course we would switch the domain and the range.